Hey guys, here's your notes on how to calculate the coefficient of friction between any two surfaces. So if a pair of surfaces are in contact, sliding past each other, uh, this is your procedure or lab procedure on how to do it. Alright, so I drew a force diagram over here, started it up a little bit, wrote down the mass of that object. We're going to find the coefficient of friction between this table and it. And there's basically, we're going to eventually use Newton's second law, and they have a procedure over here on what to do as far as physically moving stuff. The first thing we want to start with basically is that equation in the bottom left corner. That's how you calculate mu. So that'll be the last thing you use in your in calculating mu. So to calculate it, you need to know the force of friction and the normal force, and you just need to divide those two to get mu. So really this procedure is not to find mu, but can we think of it as a way to find force of friction and a way to find normal force. And once we have those two, we're pretty much done. We just divide them. Alright, so to find the force of friction is the first step in our procedure, right? We're going to pull this object horizontally with a force probe, alright? At a constant velocity. So horizontally, constant velocity are very important. You've used force probes before when you use the carts in the hallway. And you pulled each other at constant velocity with those carts too. And you know that the force probe measures Fp, the force of pull. And I drew that on the force diagram right here. Now if we pull at a constant speed, we know that the acceleration in the x direction is 0. If we pull at a constant speed, we know that that horizontal acceleration is 0 because they stay at the same speed the whole time. That was like the first step in or first trial in your lab in the hallway. Because when you pull at constant speed, we know something about Fp and Ff. Force of friction on this object that we're sliding. So if we apply Newton's second law with Fp and Ff, we know the net force is Fp minus Ff in the x direction. Mass is 10 kilograms and the acceleration is 0. Right? So if we pulled with, for instance, if we pulled with 5 newtons, that means 10 times 0 is 0. That means the force of friction would be 5 newtons. If we pulled with 6 newtons, then our force of friction would be 6 newtons, because whatever it is, they have to be balanced. They have to sum to 0, because there's no acceleration when you pull at a constant velocity in the x direction. So the way to find the force of friction in this equation is basically when you pull at a constant speed, friction is equal to your pull. They're balanced. Right? Now, the second part of our procedure deals with finding Fn to calculate mu. So to calculate Fn, the support from the table, we know that we have to calculate the weight of the box first. So that's Fg. So Fg equals mass times gravity. Mass is 10 kilograms. We're on Earth, 9.8. 98 newtons in our example. Alright, so what we're going to do is we're going to say, well, I got Fg, now how do I get Fn? Then I can finish my problem. Right? So say, we'll make Fp 6 newtons like we said, and then friction ended up being 6 newtons, and then we just need to get Fn to finish it off. Well, in this case, where we had a 10 kilogram box, Fg was 98 newtons, right? What's Fn? Well, we need to apply Newton's second law to the y direction. Fn minus Fg, that's up minus down, equals 10 kilograms. What's the acceleration of an object in the y direction? This object's at rest on a table, so there is no acceleration in the y direction. it's constant speed in this direction, no acceleration. At rest in the y direction, no acceleration. So that means Fn minus Fg has to sum to 0, or once again, they are balanced. So I'll plug in our Fg, find Fn, and whatever Fg is, so is Fn. In the x direction, whatever Fp was, so is Ff. Whatever Fg is, so is Fn in the y direction. Right? So here we had Ff was equal to Fp, 6 newtons, and here Fn was equal to Fg, 98 newtons. And we could go ahead and calculate mu in our example. 6 divided by 98. And if you got a calculator, 0.06, very low in this example. Friction was very small, so we got a very low mu. So just to summarize, we pulled at a constant speed, so Fp equaled Ff, and the box was at rest on a level surface, so Fg equaled Fn. We found Fp to find Ff, and we found Fg to find Fn. Remember to follow these procedures, right? If you don't pull at constant speed and you don't pull horizontally, Fp will not equal Ff. You need to satisfy those two conditions, right? And if you just find the weight, you get the normal force. And we proved it here using Newton's second law in the x direction and in the y direction. Now, do you need to write this out for every trial in this lab? No, but you definitely need to follow this procedure and correctly obtain Ff and Fn, and then you can correctly calculate the coefficient of friction.